So we have a working contingency plan, but we had to manually position these things, and if we load it again, they go back to their built-in positions. Let me show you how to take control over the layout, as well as start to add more checks to this. Let's start by adding checks, and then we can play with the layout. So at this point we have only one check and one repair. Let's add another check. In fact, why don't we just add a whole set of checks. Now if we look at the problems that we modeled at the top here, we modeled a network failure and a disk failure. So let's say we want to check the network, and then we want to check the disk. And if we look at the repairs, we want to repair perhaps network and repair disk. Let's see what that looks like. I've just thrown a bunch of things in here. We now have 3 checks and 3 repairs. Well, what's going to happen? Oh, I'll have to zoom out a little bit so you can see. So this contingency plan is not yet realistic. What it has done is it's automatically connected all of the checks in a chain, and the last one's connected to the first repair and connected them in a chain as well. The reason it defaults to that if you don't give it any more information is it's a reasonably common pattern that you need to repair things in sequence. So for example, with a database failure, let's say you had to replace a disk. You might have the first repair action replace a disk, followed by restore a backup, followed by restart the service. So there could be a chain of repair actions, and depending on how severe your problem is, you might cut across from each of these tests to one of these and have a shorter repair. But in our particular case here, we really do have 3 independent repairs here. We're only going to repair the network if indeed the network is at fault. We're only going to repair the disk if indeed the disk is at fault. You can see these would kind of cross over here, so we're going to need to rewire this. Let's swap the repairs around and connect them across. This can be done here. Let's say I'm just going to reorder these. That's a very quick change. So we can see we have the networks lined up. So if the disk fails, we repair the disk. That makes sense. Now if the network fails, we want to repair the network. So if the network fails, we need to go to the repair network. That gets a connection across over there. That's perfect. You notice that now that there's 2 states feeding into the repair network. The previous repair as well as this one, these transitions always connect to the incoming state there. So, and this gets positioned over here. Now the next thing we can notice about this is that all 3 repair options are in fact independent. This is not a case where we would chain them together. So we want to connect all of these back to the problem so we can recheck it. And all of them will involve a fix action. So let's do that. So that repair, we can basically apply the same set of rules to the other repairs, and then just edit the duration. So let's say a disk repair might take a bit longer, 3 time units. Let's say a network repair will be quite quick, and then a general repair could be even longer, because that's an unknown repair. So we've modeled time units now. All of them go to the final problem. There we go. Let's reload that. Okay, that's looking a lot better. Now we see that if, for example, a network fails, you repair the network and cycle back to the problems. If the disk fails, you repair it, cycle back to the problems. What we see here though is that if the network passes, we should move on to the next check. The default action of passing, going to solutions, is not correct for this one either. So let's see. Network pass must go to disk. Disk pass must go to the general repair. Network pass should go to repair disk, and the disk pass should go to repair it. And I suggest we rename this repair service to be more general. I think repair it sounds a bit silly. Let's say service, repair service. Okay, let's have a look at that one now. Alright, the network pass did not get redirected to, of course it's got to go to the check disk. I typed the wrong thing there. And network pass must go to the check disk. There we go. Now this looks a bit strange in the middle here with all of with this crossroads. That's because these two states are on top of each other. We can quite easily fix that by simply moving one of these to the other side. Like that. I suggest we put it over here to the left of problem of the initial check. So about 200 pixels to the left of that. And this will be quite easy to add by putting in a layout statement. We've managed to get away without doing a single layout. This was the repair network. Now there is a key difference between the layout statement inside a contingency plan. You notice that this layout is inside the contingency plan, and the layouts that are outside, either before or after. Inside is by default relative to the problems, to this incoming state. That's why I used a -200. It's relative to that. You can get rid of that relative by typing in an origin here if you want. With the syntax like that, or in fact typing the origin to another state, but I am going to leave it as relative. I think that's quite nice. Let's see how that looks. Okay, the repair service got moved as well. That's because it was after the network, and the auto positioning is basing it as relative to that. So I'm just going to move it down like this, and then we will be fine. There we go. Perfect. So have a look at that. This is now connected in a way that makes sense. The most important point is that the only connection to the final solution is coming out of this general testing at the top here. Is there a problem or not? So that's a good thing. Then, if we have a network problem, we repair it, come back, retest, go out. If we have a disk problem, then we repair that. If there's not a disk problem, then we go to our generic fallback, repair, whatever. And obviously we could continue to elaborate on this contingency plan with more rules, but for this tutorial we'll keep it at this point. You can have a look at the other demos of the more comprehensive contingency plans to see what else can be done there. So let's see, will this work? Shall we simulate it? Before we simulate it, I noticed that we only have two problems that we're modeling here, a network failure and a disk failure. Let's add another one that is likely to get to the repair service. And one other thing we need to notice is that we've only corrected the check statement for the first check, not for the others. We need to also model the conditions for network and disk. Alright, let's go in and do that. So put a space here so we can see between the checks. For the network, we're going to say not network. I say not because I wanted to pass if there is no network word in that. We know it's not a network failure. If I said instead match network, then it would pass if it found the word network, which is incorrect because we want we have the word network in a failure. So I'm going to say not network. And likewise for the disk, I will say not disk. And at the top here, I'm going to add to this list of failures an additional one, which I will call known failure, and I'm going to make it ready at 20. You can't see that. Let me move the screen over. You see that ready at 20 over there? I want to put bigger time gaps here. So we have ready at 1 for the first one, 10 for the second one, and 20 for the third one. The reason for that is simply that we would like to be sure that each of these completes its simulation before the next one starts. And that'll look a bit better. Alright, let's see. So we've got 3 failures coming in. We've modified the checks on these 2, on the network and disk checks. We have durations. We have everything looks correct now. Great. Let's go back, reload it, and run through this. Let's do the first one. Bang! Network failure is going down. It passes the network checks. We know it's a network failure. We repair it. It is now says network fixed. We fire the next transition and it's in the solutions, network fix solution. Great. Let's do the next one. Disk failure comes down. It passes the network check, so now it's going to do the disk check. Fails the disk check, so we know we need to repair the disk. Boom. We come up with the disk repaired. And it goes to solutions. And finally the unknown failure, boom, boom. Let's see what it'll do on the disk check. It passes the disk check, so it means it's not a disk problem. We'll go to the generic repair. We're up at the generic repair, which took the longest amount of time, if you remember. And so we're through to the end. Right, let's reset this and just simply run the full simulation as an animation. Watch it moving. See, first one goes through to the end. Then disk 1 goes in, repaired, rechecked. And now unknown goes through and repaired, rechecked. There we go. The simulation continues to run, but nothing happens because there are no more transitions that can fire. This is a complete contingency plan. If you would like to see a contingency plan where events are being generated by another network, a sensor network for example, have a look at one of the other videos where we've done a more comprehensive one.